In this video, we'll take a look at a few different types of visualizations. We'll be using Matplotlib to make all of our figures. In order to set it up, make sure you have these lines of code to get everything ready: Matplotlib notebook, and import matplotlib.pyplot as plt. Let's start by looking at line plots. We'll want to use two arrays, one containing the x values of the points to plot. We'll do x equals np.arange 100 to get 100 points, and one containing the y values. We'll just make y equal to x squared. Anytime we want to make a figure, we begin with plt.figure. Then we can use plt.plot to plot the line, x and y. Running the cell will create the figure down below so we can see the result. Let's make this figure look a little nicer. We can add labels to the axes with plt.xlabel and plt.ylabel. We'll label the x-axis arange, and we'll call the y-axis quadratic. And then let's add a title. That's plt.title, and we'll call this a simple plot. Running the cell again, we'll update all these values. We can also change the line style of the points by adding a string at the end of the plot command. If we make it RO, that'll plot the line using red dots. In this case, since they're so close together, it might be better to use R dot so that they end up smaller. Or we could do G dash to make it a green line. By changing the line width with LW, we can make the line thick or thin. Scatter plots show unordered scattered points. We'll make a new figure. And let's look at some random samples of the function e to the x. We'll use random real numbers between 0 and 10 for x. So x is going to be np.random.rand. We're making 100 numbers, and we're multiplying by 10. And then for y values, we'll sample that function, np.expx, and we'll add some noise to make it fun. Then we can plot the points with plt.scatter of x and y, and let's make it all green. Next up are histograms. Histograms take an array of data and place the values into bins, then show how many values ended up in each bin. Let's reuse the noisy exponential from before and make a new figure. We can do plt.hist, where the first argument is the data we want, which is y, and the second argument is the number of bins. Let's try 30. So here's the result. Most of the values are very small, and then there's not very many further out. We can also set the number of bins to auto as a string auto, and that'll automatically figure out how many bins to use to make the best plot. In this case, 30 was actually pretty close. This was just a quick introduction to plotting, and I'd encourage you to read up on the documentation to get a better sense of what Matplotlib is capable of.